Welcome back. This is going to be the last topic that we're going to discuss in Chapter 1, and it's about two-dimensional figures. So in today's lesson, we are going to talk about some vocabulary with polygons. So just take a minute and press pause and write this down. So a polygon is a closed figure formed by a finite number of coplanar segments called sides. The sides have a common endpoint and are non-collinear. Each side intersects exactly two other sides, but only at their endpoints. The vertex of each angle is the vertex of the polygon, and we name our polygon in terms of letters of its vertices, usually written in consecutive order. And what we mean by that is like A, B, C, D, E. So two more vocabulary words. The first one is concave. In a polygon, suppose if a line containing each side is drawn, if any of the lines contain points in the interior of the polygon, then it's considered concave. So if you see this picture over here, if I continued those lines in every direction, it turns out that they go through the middle right here and right here. Therefore, we call this concave. Next one is convex. A polygon, suppose the line containing each side is drawn. If the lines contain no points in the interior, then it's considered convex. So again, if we extended the lines in all directions here, none of the lines cross on the inside of our figure here. Next section is just naming them, and off to the side here, this is the list of naming them. Typically, you probably know maybe up to 8 at this point, but the ones past 8 and up through 12 have actual specific names. So the new one for us is probably a nonagon, so that's like 9. A decagon is a 10. A hendecagon is a 11-sided, and then 12 is a dodecagon. So if we had anything more than 12, we would just call it an n-gon. So for instance, if we had a 13-sided figure, we'd call it a 13-gon. So an equilateral has the word lateral, which is sides. So in a polygon in which all sides are congruent. Now typically when you look at a polygon in geometry, they'll have some markings to indicate that they're actually congruent. And typically that would be like little lines like this. And the next one is equiangular. So equiangular is a polygon in which all angles are congruent. And so that would be denoted with one mark like this in the corners. So a regular polygon is convex, and it has to fulfill both the convex and the, not the convex. It has to be both equiangular and equilateral. So here we have an example where all the sides are the same and all of the angles are the same. So our first example here, we have, they want us to name it, first of all, by its sides. So if I looked at this first one, I look at the number of sides, so I go back to my slide here. It's got 4 sides. So according to our diagram right here, it says we're going to call this a quadrilateral. So quad being 4, went the wrong direction. So this would be a quadrilateral. And then we want to also classify it as concave, convex, and regular or irregular. So again, with the convex versus concave, we have to think about extending the lines. So if I extended all the lines in all directions, it never happens that the lines go on the inside of this one. So this will be convex. And then in order to be regular, you need to be both equiangular and equilateral. And so that is not true in this case, so this would be irregular. Okay, and the next one, again, in order to decide if we are, first we'll do sides. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be a non-gon. And then we would decide if it was concave or convex. So I'm just going to erase my little lines here. So the convex or concave is decided by when you draw the lines and if you extend them. So we'll start with this. So if I extended that line, I extended that line, extended that line, extended that line, it looks like there's several lines that are meeting on the inside here. So this would be considered concave. And in this case, it is not regular either because obviously none of the sides are the same length and none of the angles. So, all right, the next one, press pause. I'd like you, Jack, to go through and try it, and then I'll explain it with you in just a moment. All right, well, we know, first of all, that the first thing we notice here is that it is definitely a triangle. It has 3 sides, so I'll cross this one off. All right, when we think about concavity or being concave or convex, we have to extend our lines. So if we extended our lines in all directions here, we want to know, do those lines ever meet on the inside? And the answer to that one would be no. There's no points inside of here where the yellow is intersecting on the inside. So it is convex. Okay, so we're going to be able to cross off the, make sure I have the right pen here. We're going to be able to cross off this one because it is definitely not concave. And then if it's regular, the angles and the sides have to be the same. So let's check. These sides are all the same. These right here are the same. So this would be considered a triangle, a convex, and this time it will be considered a regular. Okay, and the next one we have, again, 4-sided figure. We're not going to call this a diamond or anything like that. We call it a quadrilateral. So we'll cross off the pentagon, and we then look at if we extended the lines. So I'll switch colors here. If I extended all the lines in all directions, do any of my lines or my yellow lines meet on the inside? And the answer to that question would be no. So we're definitely going to be convex. So we're going to cross this one off. And next, what we want to do is we want to look for whether or not it is going to be. I want to get an eraser here for a second. The angles will be the same and the sides. So it appears that the sides are all the same by these marks right here. But if I look at the angles, it looks like this angle and this angle might be the same, but that is not the same as this angle. So this would not be considered a regular, it would be considered irregular because we have 2 different angles going on here. So the correct answer for this one would be A. So you'll have practice in class today, and we will move on to the last part of 6-1 on Friday. Thank you. Bye.